All right, Tim and Trevor, let's go ahead and get this started. You guys ready to kick this off?
Sure.
Let's do it.
All right. First, I want to welcome everybody to the Comparing Apples to Apples webinar that we have going on here. I want to let everybody know we are expecting a guest, Scott Allen from Ohio Valley Precision. He may be joining us late, but if he does, we'll welcome him when he joins at that time. So before we get started here, if you do have any questions, there's a questions section in the webinar area here. Please make sure to post all the questions in that area, and we'll do our best to get them answered as they arise. As well, we will also have some time at the end of the webinar to answer any additional questions, and we'll try to do that at that time. We have both the slide and presentation recorded available after the webinar is finished. You'll see those within the next 24 hours. So if you do want to share those with your team or other team members, just know that those will be coming across as well. So before we get started here, so we will have three presentation people here talking today. About 90 years of experience, so you got a lot of wealth of knowledge over the table there. On the left we have Tim Weber. He has been in the permanent mold industry for about 36 years, but when it comes down to it, anything bicycle, he's your guy to talk to. Scott Allen, mentioned from Ohio Valley Precision, should be joining us here shortly. Has 30 years experience, but he works a lot in just tooling. So he sees a lot of different types of toolings, from sand tools, permanent tools, permanent mold tools, and die casting tools. So a lot of wealth of experience there as well. And then lastly, we have Trevor Bovard, been in the industry as well for about 24 years, had some experience on the engineering side, a lot of experience as well on the shop floor and the production management side as well. So with that, the three kind of areas and sections that we're going to talk about in this webinar, really look at the tooling in the process. So really break down the different types of main processes that you'll see out there. Really understanding the difference in tooling costs and specific to those processes. And then really breaking down the tooling lead times and any of the life cycles that you would see with those specific tools. With that, we'll go ahead and kick it off to Tim and Trevor.
All right.
Thanks, Tim.
Thank you.
Yep.
Again, we're waiting for, hopefully Scott can make it. He's not that far away, but the traffic out there is sometimes kind of bad. So what we're trying to do is just every time we're working with a customer or an engineer in particular, we're talking about the tooling aspect. And what tooling, what am I getting when I purchase this tool? Is this process good for what we're doing or necessary for the type of product that we're producing? Is this the best route? So what we want to do is just kind of walk through and talk about the 3 or 4 different major casting methods: sand casting, permanent mold, die casting, and investment casting. Basically tell you, basic, setup, what the tool looks like, where its advantages are, where its disadvantages are. And we started sand. Sand is probably the least expensive process to tool up. We've all walked on a beach and left an impression in the sand. That's basically what we're doing here. We're going to be creating an impression, which will be the negative of the master pattern. Ram it up. Sometimes you put in a cope and drag, which are 2 boxes you put together, and pour the aluminum in. Sometimes it's a match plate, very similar to this. It's great for low volume, but it can also be set up to run high volume on like a Hunter machine, one of the high volume type production machines. So it can be ferrous and non-ferrous, but typically you get going with sand because it's a low-cost tool. It's pretty easy to get into. Some of the disadvantages is it's sand, so it's not quite as accurate as the other methods we're going to be talking about. So the tolerances are open, more large tolerances. The surface finish is the sand cast surface finish, so it's going to be that type of surface. It's not going to be casting up against a polished mold or into a smooth ceramic mold, so it's going to be rougher. And usually, the weight calculation, the sand per metal, that's another consideration. Goes into your costing, that type of thing. I don't know, Trev, you got any thoughts on sand tooling in particular?
Well, sand tooling is usually, like you said, you would ram up one tool per pour, where a lot of the other processes you can get, multiple pours off the same tool. So that's one big difference that you've got there. But it's a lot cheaper to make a pattern of like this nature than it would be to cut out a full steel cavity into a tool.
And it's not unusual for somebody to start out in sand either.
No,
And
not at all.
Progress on to other
Yes.
types of methods.
Yeah, things change. Estimated annuals change all the time for people, and you might start out saying may be perfect match for you, and then end up going into a different type of tooling because the product warrants it.
Correct. That's what I'm thinking. The other thing is there are some materials that you really just pour in sand, like a ferrous iron or something like that.
Correct. Yes.
Good.
So the next kind of topic we're going to talk about is permanent mold tooling. And why do you want permanent mold tooling? Well, you get better tolerances than you do on the sand side. You are cutting impressions into steel dies that are repeatable through the casting process. There's some advantages in the fact that there's multiple ways that you can gate a product in permanent mold that you may not get from the sand casting side. There's multiple ways of casting troublesome sections, so to speak, like flat walls with side pulls, different metals you can use in the tooling, depending upon how long you want to cast the product. And then, you can have multiple parting lines. That's what's a great advantage with permanent mold. Surface finish is better. You get a pressure tight casting because you're gravity fed and you're trying to eliminate the amount of porosity that goes into a casting. The other thing that you can do with permanent mold is place sand cores in it to create wireway passages or waterways for different types of designs.
Mm-hmm.
Tim, you got any thoughts?
Mold material? What's mold material, mold size?
So there's multiple mold materials used in permanent mold, and like I said, it's dependent upon the type of quantity that you're looking to get out of your tool. So you can go with a cast iron mold. You can go with 4140. H13 is your most wearable mold tooling that's out there right now. And then you can do a combination of all of them. And then one of the things that you can also do is actually cast 4140 steel tools in the near net shape if you got a real complex, geometry on your part.
Hey guys, I had a good question come across. And before I ask that, I want to remind everybody, if you do have any questions, feel free to ask those in the question section. We'll try to get them answered throughout the presentation here. If we don't get to them in the presentation, we will be sure to try and follow up with them afterwards. But the question came up, and I think you get into more details in this further on, Trevor, but a lot of the details that you provided there, does that drive certain industries to go with permanent mold casting versus a sand casting? And can you dive into that a little bit?
Yeah, it may come down to a surface finish requirement that you don't want to have to do extra operations to finish the part off, so to speak. That may be one portion. It may need to be a pressure tight vessel that has to hold a certain amount of PSI for a unit. Tim, you got any more kind of things that?
Yeah, we see a lot of the industry seeing a lot of automotive parts now. They're trying to reduce weight. So with permanent mold aluminum, you just get a denser part, you get a stronger part. We'll talk about this next week, or I'm sorry, next webinar. But with tilt pour and the permanent mold and aluminum, you're going to get probably the best properties out of that alloy per that process as compared to die casting, investment casting, or sand casting. So structural parts. A lot of that's going towards permanent mold now.
Yeah, structural and pressure tightness are probably two of the biggest that people look at when they're looking at permanent mold.
Yep.
Thanks.
So we look at the die casting now. Not too much knowledge on myself with die casting, but on the tooling side, it's very dimensionally accurate type parts. So you have to, this tooling is really dimensionally accurate. Let's put it that way, for lack of a better word. It's great for mass production on parts. So if you've got a lot of quantity that you're trying to run, then you want to look at die casting. The expense is pretty high in the beginning to get it started, just due to all the complexities in the die cast tool that you have to put into the tool itself in order to get a continuous running mold.
Yeah, die casting is an aggressive production process.
Correct.
And it's, if you've got a thin wall part and you want hundreds of thousands of pieces, I would say even starting at 50,000 pieces, you want to go die casting.
So this is an example. This little thin wall would be hard to create in sand and permanent mold just because of the size of it. But in die casting, because you're injecting the mold in there, you can get that little thin wall and cast it. And then the surface finishes on die castings are really good, just based upon how the tooling geometry is done. And you can minimize your amount of draft, so you have a lot less machining when you get done with it.
Hey, Trev, can you hold that up a little bit closer to the camera for the audience?
Sure.
What's the, would you say the biggest?
So that thin wall there is what I'm kind of talking about. That's a typical die cast application where you want to try to create, the geometry of the part is dictating the casting design, mold design.
Biggest disadvantage? Is it porosity, you think, gas and traffic?
Yeah, porosity is a big one, just because you're forcing metal into there, and if you don't have a good method of evacuation of the air that's not designed into the tool, it can end up in your casting. So you can have some problems with coating of a die casting afterwards. A lot of times die casts are raw castings. Not to say that all die castings have porosity or anything like that, but that is one of the disadvantages of a die casting.
Yeah, that's what that and is just that primarily just the startup cost.
Yeah,
It's
not cheap tooling.
No, it's not. It's not. All right, what's our next one? Investment cast. So easily the most versatile casting method. You can just about cast any shape. You can cast just about any alloy, any metal. The molds can be as simple as a 2-part rubber mold, or as sophisticated. I saw just a gorgeous investment mold this morning, and it was a 3-part mold, machined to the hilt, polished aluminum. So you get the mold, and then you inject the wax in, which gives you the master wax pattern. You put that pattern on a tree, dip it several times in refractory, so you have a thick enough wall that will support the strength of the metal being poured into it. The autoclave it or furnace it to melt out of the wax, and then you pour the metal into where the wax was. So again, it can be as simple as, like I said, a rubber 2-part mold, or very sophisticated. In addition to a single cavity like that, you can do multiple parts that you glue them together. And I think we got our guest coming in. Scott?
Yes.
How you doing?
Good, how are you?
Good, good. We just got
Scott, how
started.
you doing?
Good, how you doing, guys?
Just got started.
Okay.
We're
Yeah, this
talking-
time we'd like to welcome in Scott Allen. Again, he is the owner of Ohio Valley Precision. Mentioned earlier, he's got over 30 years in experience in mold making. So a lot of wealth of knowledge here for sure. So welcome, Scott.
Yeah, especially if you start getting into materials and processes, Scott just has a lot of knowledge. So anyway, that's the investment casting process. Again, pretty as sophisticated as you want. You can get backdraft, you can get all kinds of different issues resolved in that process. Probably the biggest downside is it's an expensive process. Every single casting, you're making a mold, you're melting the wax, you're breaking the mold, you're starting over from scratch. So it's probably the most expensive of the casting processes. However, there's just a lot of parts that have to be cast that way. They can only be cast that way. Any thoughts on this? Scott?
No, I agree 100%. I don't know the finish on a invest cast is a lot smoother too,
Mhm.
correct? I mean,
It
as
is.
far as, if you need, cosmetic.
Absolutely. Well, you think about fine art pieces, jewelry, those are all investment casting. That's a good example. But they also, we use investment castings, the industry of the aerospace industry, motors, that's all, there's a lot of investment castings used in those different types of industries.
Hey, Trevor.
Also, the material that you can, cast out of investment castings. So Tim's holding a piece up right now. It's probably hard to see, but
It's not a great investment casting. It just has to be an investment casting because of the material. You can only cast this material in investment. It's a bronze alloy. It's got certain attributes, certain qualities. So the only way this part can be made other than is cast it. You can't buy it. This part is not made in extrusion. This material does not extrude. So, it's a simple part, not the best example of investment casting other than they need that material.
which kind of leads to all the processes, right? Because, in sand, you can cast, different types of materials, even into the ferrous alloys like we talked about. On the permanent mold side, you can get a little bit of the brass and copper, mostly aluminum, zinc.
Yep.
On the die cast side, you're kind of magnesium, aluminum alloys, some zinc.
Yep.
But you can't do anything ferrous in the steel tools because, you'll end up running the tools.
Yep.
And then on the investment, like that part was specifically driven to investment by
The alloy.
the alloy.
Yep.
So.
Yep. Good.
Hey, Trev, that's a perfect parlay into my question. So thank you for setting me up here. I had a good question come across from Paula. So let's kind of think that we're either a die casting company or investment casting company, and we have a different process, but want to transition maybe into permanent mold. Are the parameters the same that you're looking at for each individual casting process there, or are you looking for different either surface finishes or wall thicknesses? What are the kind of the restrictions that you would see kind of across that stuff?
Well, on the parameters are similar, but not the same. There's an advantage for each one of the processes. So die casting typically has a certain type of alloys that have to run for the die casting routine, and the same for permanent mold. And in the permanent mold, since you're not forcing the metal into the area, wall thicknesses are typically larger than compared to die casting. But it's what you can give up on the part design to match the process. So if you want to go from a sand casting, wall thicknesses, things of that nature, kind of transition into permanent mold if you're looking to get more parts out per year, but maybe not necessarily transition from permanent mold to die casting based upon the design of the part. You may have to look at some redesign features. And the same with the investment casting. It can probably incorporate all three things, wouldn't you say? But it's still kind of what you're wanting to do with the product, the end game of the product.
We draft radiuses, those type of things are important. But you're exactly right. That's the route to look at it.
Yeah.
And like you mentioned, I think before, the investment casting, some of the stuff you're not able to manufacture, something that won't draw correctly, or you just can't, manufacture it. You can get by with the investment casting, for some of those hard applications that you just can't do with a permanent mold or, another way of casting the part.
Yep. All right.
Thanks.
Sand cast costs, real quick, just a couple rules of thumb on your last question, Tim. So wall thickness is between, for instance, the permanent mold and die. Typical wall thickness on die casting is a minimum about 40 thousandths.
Yeah, about a millimeter.
Yep. And die and permanent mold is
3/16
okay.
approximately.
Sand is similar.
Yeah, similar.
And you can play around with wall and investment casting, do a lot of different stuff like that. Sand cast costs. You want to dive in on that one, Scott?
On the sand cast cost, I mean, that's you're dealing with sand, so you got a lower cost, as far as, the process, I guess.
Mm-hmm.
But then the sand cast cost, you know, as far as the tooling goes, it depends on how complex you get there. Because you got your, you know, you got an ISecure type box or you got a shell box. So you got to kind of weigh out the cost, you know, as far as what kind of core you need. But, you know, as far as the tooling side of it, you know, depends on, you know, how high of a runner. It kind of goes back to everything. How high of a runner is it? How complex is the box? How complex does it have to be? Is going to be a big driving, you know, you want a multi-cavity type core box, or you're looking at a single cavity just on account of the production run.
What's a sand tool made out of? Not the core box itself, but what have you made sand tools out of? What's the
I mean,
options?
you got cast iron. I mean, even on some of your low running ISecure boxes, you can make them out of aluminum. I mean, on a really low runner, but obviously the sand is abrasive. So typically they're going with some type of tool steel. You know, you can go with like a 4140, you know, which you'll get good life out of. But if they got something that they're really going to run, they're going to go with like a tool steel, and then they're going to harden it. You know, I mean, they might go with a hardened D2 insert in the box. It's going to show a lot of wear. But I mean, you know, the better quality tool steel, the more life you're going to get out of, and that's just going to be kind of dictated on how high of a runner it is.
Trev?
Permanent mold, so, you know, permanent mold ranges, and it's all dependent upon how complex geometry your part is. So you can get low cost, when I say low cost, you're probably in the $10,000 range up to, you know, $80,000, $90,000, depending upon how sophisticated you get with pulls and the design of the part and how many cavities and all that kind of goes into the design of when somebody comes to you and looking at that. Essentially, you know, on a simple tool, you're looking at two-parted tool. You got a simple cavity, and you're just pouring the metal and pulling the part out. On a very, very complex tool, you may have 6 pulls creating undercuts that you need to pull out, and then it goes in a sequential operation. And, you know, all that has to be accounted for on the tooling side. So each one of those pull pieces, it has geometry that has to be cut to match the part. So you've got 6 of them that you got to cut, not only the cavities for both the top and the bottom half. So there's a lot that plays into that. Scott, you probably got some good knowledge on that.
No, absolutely. And I mean, like when you're, you know, when you're dealing with engineering on making a tool, I mean, the engineer can, you know, can make that simple project very complicated. So, I mean, or the other way around. I mean, you know, it depends on what you can get away with. I mean, do we need to cast that geometry into the part, or is that something that's so minimal it's not worth the cost of trying to put it in the mold? We'll just, you know, it's a machine face, we'll cut it in there anyway. You know, there's a lot of different options on how detailed you get it. I mean, the engineering part of the tooling, I mean, it really, really dictates the cost of the tool. You know, how involved it's going to get.
Yes.
As there were some details on the previous slide here, I'll go back real quick about, you know, fixtures, so sawing, you know, what kind of fixtures you're seeing. Good question came across. You know, that's stuff to keep in mind as you go across every type of casting category, correct?
Yeah, I think we talked about this prior, is to kind of determine the end before we start cutting metal, and, you know, and then work with the foundry, you know, as far as what do you absolutely need, and versus, you know, what can be manufactured. So you're exactly right, Tim. That's a good point.
And I guess to that point, it would depend on the company or the casting process you're working with too, to understand whether they have this type of capabilities in house, or you're going to see this type of cost external of just the casting alone.
Yeah, I think it's important that when you're talking to the foundries, whoever you're choosing, make sure they've got design capabilities that can help you out on that kind of thing. You know, draw the engineers in, the tool guys as early as possible. In the long run, it's going to be cheaper. It's going to be, your time to market is going to be a lot better, more improved. It's just, you know, as early as you can get those guys involved, the better off you're going to be.
Definitely a team effort.
Yep.
Great, thanks.
So, die casting. Die casting is probably your most expensive tooling out there. A lot goes into a die cast. There's typically cooling, jackets that need, water jackets that need to be cut in for these tools. There's fins for cooling. You got to imagine, this part is running under pressure. We're forcing liquid metal, 1300 degree metal into typically 13. I'm just using aluminum as an example into this, and we have to evacuate that thermal quickly in order for it to be rapidly repeatable. And that's why these are used mostly for mass production. Your cost can range, 60, 70 probably, all the way up to $500,000, depending upon how much tooling you need to support just the die cast tool. I mean, you got trim dies, you've got all the other things that kind of come into play when you're talking die casting.
Yeah, it's die casting is just scary fast. I mean, you see a die cast machine running, man, it just flies. And they're built to withstand that.
Yeah.
But that's what they're built for. So if you got a high runner, man, that's the route to go.
Right.
Absolutely.
Investment costs are investment cast tooling costs. They're typically in between a perm mold and a sand casting. Again, everything we've talked about here earlier, it's just how involved they are. Is it a single easy two-part? Is it got multiple poles on it? Because you're injecting a wax-like material, the wear on the tool isn't that aggressive, so you get a long life out of it. But the costs are fairly. I think they're easy to be able to handle, easy to digest. On the low end, we've seen $6,000 tools, and probably the most expensive investment tool I've ever seen is in the $50,000 range. Multiple cavities, multiple pools, that type of thing. So relatively on the lower end of the cost of tooling would be investment.
But again, keep in mind that the piece price,
Is gonna be-
because each one of those wax parts ends up being,
A little more involved.
yeah,
Go on.
And from what I understand, I mean, most of your castings, I mean, they range from relatively small to like a 20-pound range, right? I mean, they don't really, I think they get into some big investment castings, but I think that's like a common area, size-wise.
kind of the wheelhouse.
Yeah.
As investment casting gets bigger, they get extremely expensive.
And maybe we ought to talk about that a little bit. Sand casting, you probably produce the biggest castings out there poundage wise,
In
right?
production. Yep.
Yeah, in production.
Yep.
Permanent mold's probably your next biggest.
Mhm.
In die casting, you look to the small lightweight parts typical for what die casting is,
Yep.
up to about maybe 50 to 75 pounds. That's probably kind of pushing it. That's
Right.
an awfully big tool.
Right.
For a die cast. And then your investment casting, like Scott said, that their wheelhouse is that 20-pound range, max type of thing. So
Yeah.
that's something to keep in mind too, is, what kind of weight are you looking at with the part that you're wanting to produce?
That's a good point. Lead times. You're the tooling guy. We're calling you when we need to.
Kind of back to what Trevor said, if you, as far as the cost of the tool kind of dictates the lead time of the tool. So you got a simple shallow cavity 2-part tool, you're not going to have too much of a lead time on your material to get to the shop. And, you're looking at probably 4 to 6 weeks, depending on the complexity of it. And something we've talked about before, it's like, even if you have a simple part or a job, it looks very simple, but like if you get into a logo or anything that creates little tiny detail, for the shop that's manufacturing that tool, I mean, you're looking at smaller tools, higher RPM, smaller picks. So you might look at it like it's just a little logo, it's 4x4, but it's got real intricate detail. You could be looking at 20 or 30 hours of spindle time to cut out that little detail of that part. It looks simple. So, I mean, again, it kind of goes all back to the complexity of the mold. But I'd say on average, you're looking at 6 to 8 weeks, typically on most your standard molds. You get into, like we mentioned before, you get into pullbacks or these multi-parted, type cavities. They get pretty complex. So you got the machining aspect of it, and then, the putting together, the plumbing of the cylinders, the fitting of the parts to make sure everything kisses home where it's supposed to. And, all that can be very time involved. So, I mean, a job like that, you're probably looking at, anywhere from 10 to 12 weeks. So.
Hey Scott, with that, I had a good question come across. Is that timing with somebody coming in with a design already set up for sand casting, or does that include kind of working time to get the design ready for that design for the sand cast to be created and designed out?
That's pretty much included with, the design is being part of it. Because, a lot of times, if you got customers that you've worked with, I mean, at the end of the day, you're going to know the envelope they're looking at. So, I think a lot of companies will typically say, hey, we can get the material on order. We'll figure out the small detail on a date code or a logo or whatever the scenario is, an injector pin, and you always can fill in those details, but you kind of keep the project moving forward kind of thing. So typically that lead time includes, finishing up on the design work or part of the design work.
Great, thanks.
We'll say the devil's in the details, and that one little detail
Absolutely.
may take you a couple weeks.
Well worded.
So looking at permanent mold, as far as lead times, it's kind of banking right off of what Scott said here. It's kind of dependent upon how difficult the tooling design is after you get the part design for manufacture. It's kind of how difficult it is for that tool to create that part. So if it's got a bunch of pullbacks like Scott's talking about, if it's got multiple amount of ejector pins and we can't see these ejector pins and we got to do something there, or, it's just kind of all in those details that kind of drives that lead time. But I mean, if you're talking, simple to medium hard type of tool, you're probably looking at, 10 to 14 weeks, depending upon that. Once the design's baked out and we're good for manufacture. So.
Yeah, and I think we almost scare people off too. I mean, castings are cool. There's stuff you do with a casting that you don't really do with other processes. So if I'm a designer, I ask for the world. I bring it to you and it's got ribs and it's got logos, and you come back and you say, look, if we put the logo over here, we can do it. And it's not going to impact too much. Or if we put draft on these ribs, or, additional draft, or a lot of draft on the logo and not so much, I think we need to keep in mind that, there is a reason to go to a casting, because you can do so much with it. There's so many options.
We're taking it from a fabrication to, a casting.
Which we do a lot.
Which
is done a lot. You're right.
Absolutely.
So die cast, do you want to talk about that one?
I'll let Scott talk about that one.
I mean, die cast can be very, very involved. With what background I've got in it, I mean, there's so many fine details to it. You got, like Trevor mentioned before, you got your cooling fins, your cooling tubes. I've seen companies where, they've, just their cooling process to get that water to that area that they need to chill. It could be a pretty complicated orifice that goes in there. I mean, it has to be line bored with a thread, and they want a thermal cupping on it. So, I mean, it's very involved. When you're dealing with something like that, I mean, your fits on it are going to be very tight because it's going to be pressurized. So you don't want, any of your offset partings, all that has to seal off really good, because, you obviously don't want this material to be squirting out into the mold itself. So there's a lot more precision in that type of tooling. So with precision means longer lead times and a lot higher dollar price tool.
Yeah, probably a lot more checks and balances while the tooling's being made, right?
Oh, absolutely.
You know, cutting out a big pocket or something like that. I mean, I've seen you have to take them out, send them out for stress relief, come back in, retram them in,
Yep.
face them back off with a little bit of stock that was left and things of that nature.
Yeah, you get something that has a tolerance of, for the tool, a 0.5 to 5,000 tolerance. That's a big spectrum in a manufacturer's world. I mean, for making the tool, because if you're dealing with a 0.5 that means everything's got to be just right. So, you got to pay attention to detail, which takes time, and time costs money.
How many molds have you designed, Trev?
Oh, boy.
In the past life, Trevor was a tool designer, mold designer.
Still is.
Still is.
I'd be maybe 200 plus. You know?
How many casting tools have you made?
Wow. Been doing it for 25 plus years, so I probably in the realm of over 1,000, I would say.
That's what I was
That's
going to guess.
I mean,
That's a lot.
Yeah.
yeah. And I mean, and I like, kind of like what Tim's saying, I mean, the casting part of it, I mean, there's every single tool or any particular job you do, I mean, there's so many directions the job can go, and it's all for a very good reason. I mean, at the end of the day, you're looking at, you got to make all these decisions of, the casting. I mean, even when you're shopping around looking, is it going to be cheaper to make a die casting or permanent mold? And that's all part of the decision making, and that's what we all try to help the end customer, make that decision to where it's going to be, depending on the volume and where this project's going. I mean, you could save a lot of money and a lot of time, just with a little bit of forethought on it up front.
So investment castings, lead time on investment tools can be, it's going to be typical or a little bit quicker than a perm mold. Because again, you're typically making something out of a solid or casting it. So, 8 to 12 weeks for a typical lead time. I've seen them as much as 16, but they're not too hateful. They're pretty straightforward, and you can get them kind of quick. You don't have a lot of the issues you've got to have with some of the other methods. Again, it's so versatile and repeatable. If you need an investment casting, the tooling life is not going to be an issue.
Yeah. And plus, it all kind of depends upon that design too. If you got some undercuts in there that you got to be able to cut into the tool itself, to create whatever, then that's going to cause you some time too.
And we talk a little bit about repairing. It's typically relatively easy to repair an investment mold. That's typically not tough. Similar, I think, to sand casting. A little bit more involved for perm mold, and then die casting is okay, but again, you got to tear that whole mold down. It's a lot of effort just to tear it down if you've got to make a cut versus the other three methods. So very doable, but again, it's kind of depending on which process and how much work you need. But all four can be done.
Guys, I think with that, so these are the three sections that we hit across here in the four specific processes. We did have some really good questions come across. I'd like to get answered now. And again, if you do have any additional questions, please put them in the questions section here. But they're a little more specific. Can permanent mold be modified to accommodate changes? So you guys have mentioned it being cut into typically a steel mold. Is it easy or is it modifiable to make changes as they come up?
So to answer that question is yes, it can be. Now, the best way is if the tool is mold safe, that's the easiest way. If it is not mold safe, and what that basically means is if the cavity or is getting bigger or the core is getting smaller, that's metal safe. If you've got to go the other way where the core gets bigger, you probably have to make a whole brand new piece. And if the cavity gets bigger, either you're going to have to probably insert the tool or you're going to have to weld that tool up and recut. So it's all dependent upon what you're trying to do there. But yes, fairly simple to do changes in permanent mold. It's just costs are different depending upon whether it's mold safe, metal safe, or not metal safe. Scott, you probably got some good.
Well, I mean, here's some kind of question for you is like, I know, if, say this mold, you're in the bottom of a pocket, and you can't weld it, and you're looking at, say it's a big mold, a high dollar mold, and then you got to go about putting an insert in, but then you got to be careful too for that heat affected zone, right? I mean, that's, you got an insert, the mold's going to be at a temperature and you've got this insert in here, you got to make sure that
It's not going to affect.
it's not going to affect the casting, just on account of everything, being equal, thermal expansion, where it's at. It's all very doable, but there's some things you got to think about, in the repair part of it or a change.
Thanks, guys. So another good question here. So you could fit one part into a bunch of different processes, I imagine, but there's often deciding factors that direct you a specific route. Could you talk about maybe some of those in terms of, permanent mold to sand casting or sand casting to die casting?
Yeah, it'd be that part right there. Prime example, Tim. This part can be made out of sand. It's small enough to probably be made out of die. It can be investment cast and it can be permanent mold. But the reason that this part was driven to the investment was because of the alloy that had to be used to make it. So that's kind of, a simple explanation of why it would go that route. This is another explanation, which I showed earlier, which is that wall doesn't really have a good chance of being machined with that depth and that type of slot width. So it lent itself to a die casting.
Hey, Trev, so you showed me two different parts. Is it safe to say that it's really specific to each part and each end desire for the product and its life?
Yeah. So, I mean, you can cast this part in permanent mold, less some of these features, so to speak, but then you'd maybe have to do secondaries to get it to look like the outside shape here, right? Whereas die casting can get you everything that you need right off the bat.
Right.
It's a good explanation.
High volume part.
High volume parts, yeah. Alloy driven.
Yep.
And a die cast too, your finish is usually a little bit better,
Yeah, it's superior. It's one of the superior.
if it's going to be a cosmetic item that, is going to go on a car or whatever, and they don't have to do any other kind of machining or finishing, that end product's going to be a kind of a prettier, maybe more tight tolerance part out of the get-go. And that would be kind of a deciding factor too.
Scott, this might be a good question for you. Not 100% on your experience in this, but is there a reason die casting molds would have a longer lead time than like a plastic injection mold?
That is a good question. I mean, really, at the end, I'd say they're pretty much created equal because, I mean, again, both those type of molds are very, very tight tolerance, because, your plastic injection, same as a die cast. I mean, you're injecting the material in there. So at the end of the day, you're still looking at, everything has to be perfect. So, I mean, depending on the complexity of it, your plastic injection mold, one benefit for your lead time, you're typically looking at, aluminum. It's a little bit more of a lighter weight, lighter duty type tool, as a die cast is going to be a little more, you're going to have more tool steel in it, and everything, your guides and your slides and everything are going to be a little more heavier. So, as far as the tolerance is going to be the same, but you're looking at a little bit more of a lighter duty tool versus a heavy duty tool. So it's probably going to be a little more on the die cast side, lead time wise.
Yeah, so I would say on aluminum, you can take, heavier rough cuts versus tool steel where you're going with a lighter.
Yep, it's easier. Yep, aluminum's a lot easier to cut.
Tim, this may be a good one for you. Could you kind of walk us through the typical draft angles that are required or looked at for the 4 processes we talked about?
So sand and so die casting's probably got the least amount of draft, along with investment casting. Investment casting can get almost 0 draft. I mean, you've got to get the wax out, but measurably it has almost no draft, or can. Die casting, you can typically go with 1 degree, sometimes 2 degrees, because with the die casting, what they're doing is misting a graphite or a coating like that every single casting, and they've got a tremendous injector system. Permanent mold, keep in mind permanent mold, we have the steel cavity, but then what we're doing is coating that with a refractory. So that refractory has to stay on the mold walls. It has more tension, the more tension on it, the longer it's going to last. Less draft, that mold coating is going to break down. It's going to affect the surface finish. You're going to be tearing that mold down and coating it more often. In a perm mold, they try to coat it typically once every 8 hours or something like that, and just touch up. But again, I think sand would have a similar type of draft requirement. So, 3 degrees minimum. You can go, the more you give a foundry, the engineers love that. It makes your mold last longer, the part kicks out. If the mold mechanically runs well, you're going to get good castings every time rather than fighting it. So, good question.
Guys, I think that's all we have time for right now. I appreciate everybody joining the webinar this afternoon, and I really appreciate the moderators we had over there. All the information that you were able to share with our team. Our next webinar will be Tuesday, February 9th at 1 p.m. It'll be on FEA analysis for metal casting. We do have guests for that one as well from Magma Foundry, one of the leaders in that technology. So we look forward to seeing from you then. And as I mentioned earlier, we will be sending out the recording of this webinar and the PowerPoint for your viewing. If anybody has any additional questions, feel free to reach out and we'll get them answered for you. Thanks, guys.
Thank you.
Thank you.